The ready, set, go for 3.4 is a little bit quicker on the ready portion in terms of what I'm going to be helping with, but we're talking about linear and exponential functions. So the big thing to keep in mind here when working with linear and exponential functions is understanding what those mean. A linear function is going to create somewhat of a line, not somewhat, it's going to create a line. Whereas an exponential function is going to have a curve to it. So then it's your job to create characteristics of each function. What are the similarities? What are the differences? For example, one of the similarities might be once a linear function is going up, it will always go up. Once an exponential function goes up, it is always going to go up. So it will maintain a consistent increase or decrease. Just the rate at which it will increase or decrease may be different. For the set portion, we're really working on that domain range, increasing, decreasing, and interval notation. So for number 3, a couple of key things here. Okay, first of all, we see that arrow pointing to the left. So we know that the domain in interval notation will be from negative infinity, and it will go all the way up to right here, which is 4. Now the range is our y values. It's going to keep going closer and closer and closer, but it's not actually ever going to hit 0. So we can say that it's going to go to 0 but not actually touch it. Actually, we'll go from lowest to highest. So it's going to start at -6, and that open circle means that we're going to have that open parentheses, and it's going to go up to 0. And we can say that this is a decreasing function because from left to right, it is going down to that open circle. For number 5, the domain is all of our x values. So this time, it is a closed circle, so the closed bracket there, and it's going to go from 1 to 6. Okay, don't get confused by this 5, that's there, it continues on. It's a continuous function between 1 and 6. The range, clear this out a little bit, goes from here to here. So -2 to -1. And we can say that this is increasing. Number 7, the domain starts here, continues on and on and on, and that arrow tells me that it's going to go on forever. So it'll go from -5 to positive infinity. The range, starting from here, not from there, from here, and again that arrow means that it's going to go up to positive infinity. So we will start it at, let's say, 1/2 and go to positive infinity. And this is increasing because it's going to continue going up and up and up as we go. For number 9, our markers there have arrows on both sides, so the domain is going to go from negative infinity to positive infinity. The range starts out at 0 and goes up to positive infinity. And this function is decreasing. Looking at it from left to right, you can see that it's going down. And in the Go section, here are those wonderful explicit and recursive equations. Looking at number 11, for the explicit, I need f of 1. So I need to get the pattern down. So that's 4 to 8, 8 to 16, 16 to 32. So we're multiplying by 2, which means that my first term would have been 2, and continuing to double on. So then we would say that f of n equals f of 1 times the common ratio to the power of n minus 1. For your recursive, you have really how you want to lay it out there. If you want to put f of 1 or f of 2, I'll put f of 1 since we know it. And we can say that f of n equals the term right before it times 2. For number 13, f of n equals f of 1 times your constant ratio to the power of n minus 1. For your recursive, define your first term, and then take your previous term and multiply it by 3. For number 15, you've got 6, 9, 12. That gets a little bit challenging. And you can see that we are going up by 6, going up by 3, which really kind of throws us off a little bit. Let's take a look back here and go back 3 more. And we would say that we were at 1. Okay, so really what's happening is every one step, we're going up by 2. It's a pretty challenging concept, but we can work our way back knowing how we got forward. So now that we have it, we have f of n equals negative 3, and we are adding 2 each step of the way. And you have your explicit equation. If you wanted to simplify it, which would be fantastic, you would end up having 2n minus 5. For your recursive, the first term that we have defined here, I'm going to put it as 6. Oh, nope, yep, f of 6 equals 7. And this is an arithmetic sequence, so we'll take it as f of n equals f of n minus 1 plus, for each step of the way, we're going 2 units. Don't get tripped up by the fact that it's jumping by 6 because the x value is actually jumping by 3. The last problem that we'll do here, number 17, 2, 3, 4, is now going 16, 4, 1. Oh no, we're taking and we're multiplying it by 1/4 each step of the way. So going backwards, we know that we are multiplying by 4. So our first term is 64, and our constant ratio is 1/4 to the power of n minus 1. For our recursive, the first term we know is 16, so that's our n equals 2. And f of n equals the previous term times 1/4. Hopefully this helps. Let me know if you have any questions.